name is Mattias Carlson, and in this short video we'll go through a couple of tricks and a few common problems that you can typically encounter while importing black hole tables into Harmony. The first thing I would like to show is that earlier we remember that when we imported these saturated properties, we imported them, the saturated properties here, and then the unsaturated properties here to the right. But actually a trick that you can do is to import the entire saturated and undersaturated properties for both the BO and RS in this column right here. Then if you import the saturation pressure in this particular column, which is in this case an example we worked on earlier, this number right here, we'll see that this box just automatically filled out. Another thing we can do just to make sure that call it the fluid initialization has been done correctly is to go over to the analysis tab right here and look at the plots. So now we've essentially been using this black hole table to run a simulation with some appropriate properties, and we know that the saturation pressure in this case that we have right here, that we find in fluid init data, is around 4,700 psia. Before the bottom hole pressure drops below the saturation pressure and we get this kind of solution gas drive behavior right here, we should have a constant GOR, which is the same as the GOR that we inputted in the table, which is 2000. So that's also just a nice kind of quick QC that everything is done correctly. If you have a saturated system or a two-phase saturated system, what I recommend you to do is just to take a very high initial reservoir pressure just to make sure that the fluids part is correct and that you see this constant GOR or CGR trend before you're dropping below the saturation pressure. The other thing that I wanted to mention is this thing about or what will happen when you run a simulation and if you don't have consistent dew point and bubble point pressures. So in this particular case, we can see that we have the condensate bubble point right here and the gas bubble point or the gas dew point right here. And let's say I just changed this slightly with just one digit from what we had initially, and then I go back to the simulation. We see that we get an error message down here that says that the oil bubble point pressure is inconsistent with the gas dew point pressure. So always make sure that when you everywhere where you import these values, to import them such that they have the same number of significant digits. So when I go back here right now, I have no errors in the status window down here, which is very, very good. Except from that, there is one last thing that I'd like to show. Sometimes for near critical fluids, so when you have a very steep shrinkage curve or a very, very steep liquid dropout curve, depending on whether you are a dew point or a bubble point, your simulations or Harmony can actually struggle with converging, like numerically converging. What will then happen is that you might have a simulation that runs for a few days, maybe typically actually before the well drops below the bottom hole pressure drops below the saturation pressure, and then Harmony crashes. And in those cases, what we recommend to do is to go into the oil slash condensate pane, because that's the one where typically this problem is encountered. When we talk about a shrinkage curve, what I'm essentially then referring to is this formation volume factors right here. This is a volatile oil case, so you won't have that much of an issue with it. This is a fairly smooth curve. But for a very near critical fluid, this curve, instead of dropping like this, would drop almost vertically down right here. And the numerics of that can be challenging sometimes. So just to avoid, or if you have that problem, what we recommend you to do on the PVT correlation side is to change to the Verlardi correlation. And I'll explain why we want to change to that correlation and not the other ones. And then you see on the plots here, you'll have the custom data imported and an untuned Verlardi correlation that we would like to actually tune to get a decent match of these properties. The first thing to mention here is that if you can't see the custom data points right here, it's simply just to click this button right here, and it will hide and unhide the custom data and the smooth data from the Verlardi correlation. Then we'll use this calibration properties pane right here. We can try to import the saturation pressure there. The temperature is what the reservoir temperature is. The RS should be 2000, and the BOs should be very close to 2. Let's say 206, it looks like 206. And we see already that we have a very good agreement of this correlation and the custom data. The more near critical we'll get, the more differences we'll actually observe, and the more issues we'll then have, and the worse actually the Verlardi correlation will be. The reason why we like to use the Verlardi correlation is that compared to a lot of the other choices here, it has some call it non-linearity built into the correlation itself, while a lot of these other correlations are linear relationships.